let's see another problem. Remove all duplicates in a string. Given a string, recursively remove adjacent duplicate characters from string. The output string should not have any adjacent duplicates. Okay, this asks us to do it recursively, but I think a stack is more intuitive to me, and maybe in the future videos I will do a recursion version, but I still want to record my thinking about a stack. So let's see how to solve this by stack. So let's see the example. Yes, this is easy to understand. We have this x removed, and then we can remove the z, and the rest is ay. And the next example, we remove aaa, and then bbb, and aa again, and c will meet this, the first z, so it is deleted, and then d. Okay, and the next, we see this AAA, so we'll remove this and remove this BBB, and then we cannot remove the A, we cannot remove the C, and DDD removed, so AC. Okay, so using a stack is good because if here is not an A, if this is a for example here we remove the A, and B, and AA, and this C can meet this C. So this reminds me of a stack. So we remove the top, and then we can review the next top. Let's draw a stack. So the duplicate, it can be duplicated twice or 3 times or 4 times. It's not a fixed number. So I think that is the hardest part of this problem. Because if it's just all the duplicates is only 2, like this one, like AZ, X, Z, Y. If all the duplicates are just paired, like 2, then we can just put in this A and Z and X, and C next is S, so we just pop this out. And next is Z, and we just pop this out. But here, we don't know how many times this is repeated. For example, there is another X here. So it's AZ, X, Z, Y. So when we put in the first X, and when we see the second X, if we pop it out, then next time when we see the third X, we thought, okay, we've never met X because our top is already this Z, right? So maybe we will only put in the X again, but we don't want this. So we cannot pop the X the second time we see it. We need to keep it there and count it until we meet something that is not an X anymore. So to improve this, let's draw another stack, and this time I'm going to store the count of the character. So A, we saw it once, and Z, we saw it once, and X, we saw it once. So next we see an X, we will update this to 2. And then next we saw the X, we're going to update it to 3. So now inside this stack, now it's a list of length 2. And the first is a character, the second is the frequency. Now we saw it a third time. So then we met this z, and this z does not equal to the top stack. So we are going to pop the x out, because otherwise we will lose the chance to ever pop the x out. So when we see z, we're going to pop this out. And then we check the stack again. Now the top is z. It is equal to our z here. So this z meet this z. So this z now need to pop out. But just before we do that, we need to put this in first and update its number. Why we do that? Because what if we have another z here? If we pop it out, it's like before, we have lost a chance when we see the third z. So we just update its count. So next time if we see another z, then we will update it again. And now we are at the end of the string. So we are ready to check what's still in our stack. Okay, the top of our stack has a count of more than 2. That means it is duplicated. So we need to finally check this and do a final check to make sure there are no duplicates at the top. Okay, now I think we are ready to write some code. Solution. So if the string is empty, we just return the empty string. And if it's not empty, then we can put in the first element in our string. And so the first element is s and index 0. And its frequency is once. So too many brackets there. Okay, next we're going to loop through the whole array from index 1, since we've already put the thing at index 0. So now let's check if stack is not empty and stack top frequency it's not frequency, the character is equal to the first si, then we can just update its frequency by 1. And else, if the stack is not empty and the top of the stack is not equal to the next element in the string, not equal to si. Then what we do is we should check if we need to pop out the top. So if the top's frequency is equal to or bigger than 2, then we need to pop it out first and then put in our new item. So if the stack is not empty, we should always check if the stack is empty, because if we don't, then when we do the index -1, it will be out of index. 2. Then we should pop the top. So in this case, the X is out, right? And then we will check if Z is equal to the top. So now if the stack is empty and the stack -1, 0 is equal to the item, then we need to do this, right? Update this. Count. Otherwise, so we update the count is now it's like 3, and then so it's 2. So this is the one case, and the other case is it's not equal to this. So else, for example, this is a y, so it's not equal to z. So we just put in y. Stack dot append this new element, and the frequency is just 1. Okay. Now, so we have checked that if stack exists. So what if the stack is empty? So else, that means the stack is empty. Then we just append the new element and this frequency. Okay, and so after all the checks through the original string, we have got our stack, but we have to do the final check. Okay, final check is here. If stack top frequency is greater than or equal to 2, it means there's duplicate, so we need to pop it out. Okay, so now let's do our final result. We're going to our expected output is a string, and we have a stack. So we're going to put the content of the stack into a string. So we're going to initial a string, an empty string. And then we can loop through the stack. For item in the stack, so we're going to concatenate what's in the stack to the result. So result equals to result plus item So the item and index 0 is a character, and the item at index 1 is the frequency. So we can multiply the character with the frequency. For example, so if we multiply A by 2, then what we get is AA. So we're going to concatenate it to our to our result, and then we can return our results. Okay, that's it. Thank you for watching. Bye bye.